Our final talk for this session is from John Archer and Audrey Resnick, and it's going to be all about Kubernetes and democratizing data science.
One thing I want to understand here, how many guys here are data science developers? I just wanted to understand who's actually doing it.
Don't be shy.
Yeah.
Come on, put your hands up.
Who's here to learn what the heck all this stuff is? Okay. All right, cool. One of the things I understand is I want to be able to talk to developers about developer things, but is there anyone who call themselves a data science operator? Would anyone want to raise their hand and say they're doing that? Yeah, keeping the thing healthy, keeping the thing running, supporting the platform, right? What we're going to talk today about with Kubernetes is this is a technology that I guess let me back up one more thing. Who knows what Kubernetes is? Okay. Anyone using it? Using it in pain? In anger? So part of what we're trying to do is reduce the pain and anger associated with Kubernetes, okay? So we'll get into all that. But in any case, I'm with Red Hat now. I've been worked in Oracle and a few other places. I've got much better once I came to Red Hat. Some of my anger leaving Oracle I left behind. But what Red Hat really is, we're a very different software company. We don't really build software in a traditional sense, right? We're not a vendor like where we go build software and then try to sell you a license. What Red Hat does is try to build communities, right? So like this event to me is a community event, right? And that's something that we need more of, right? And we need more venues like what Rice is doing here, not the mafia of some of these other energy events that are out there. You should not be trying to monetize getting people together to talk and share ideas, okay? And I think Rice has done a very good, this venue, getting these people here to, not just the economics, but having students, having alumni, having, the operators, the service companies all get together. This is the kind of thing we need to do more of. So, but in any case, so that's enough about me. Audrey, you want to?
Okay, so my name is Audrey Resnick. I'm a data scientist with the ExxonMobil Upstream Research Company in the Data Analytics Group. I'll just refer that to the Data Analytics Group from right now. My background is a little bit different. I was a software engineer in the .com industry for approximately 10 years before I joined ExxonMobil. So dual degrees, dual experience in software engineering and geoscience. That could be a blessing or a curse, however you look at it. And currently what I'm doing is I'm using OpenShift to basically help me work with and analyze data, but more so to provide a reproducible and an interactive scientific data science environment where I can share my code and where I can actually share my proof of concepts or my applications with my users.
Go ahead. Okay. All right, so real quickly, I'm going to talk about what, I go out and talk to a lot of different folks trying to figure out how to, a lot of firms have been building data science teams over the last 2 to 3 years, right? Now, I'll make the argument that they've been there, but we call them BI guys, potentially, or guys that did stats, right? So if you're a BI person, maybe you reclassify yourself as a data scientist, and you're just using more tools, right? So the Tableau users, I'll go back, Cognos and Crystal people, if you go way back, or Actuate. All those tools, what's been happening is these open source projects have really accelerated, right? So where Red Hat tries to go and find where innovation's happening and where where things start really allow developers to create agile things for data scientists, but developers at whole, that's where Red Hat comes in and tries to support those communities. So we'll talk about what Kubernetes is a little bit later on, but for data scientists, basically, a lot of data scientists I've seen, they're really good at taking a CSV in on their desktop and spitting out a CSV file on their desktop, right? And they might have a great algorithm, but there's challenges in getting that productionized. There's challenges in enabling it and getting out, particularly for oil and gas guys, getting it into the field where they can interact with that algorithm in a meaningful way and get the value of what the data science has built to impact the business, right? So things that are business outcomes, data scientists are, I think there's a bubble right now of getting these things out to where it's impacting the business in a quick, easy, DevOps, agile way. And so that's what we're focused on. So you want to talk about what you're seeing in your groups?
Yeah, I definitely can. Okay, so there are going to be two parts to this presentation. The first part of the presentation I'll take over, and I'll basically be going over the journey that the Data and Analytics Group had in URC for trying to find some sort of integrated and kind of interactive and reproducible data science environment where we could share our code and share our applications. I'll be going through that, and then John will pick up later on to take a look at the nuts and bolts of OpenShift. So first of all, hands up for anybody who kind of feels any of the pain that might be here on the screen. You don't have to be shy about that. Some of these data science pressures were not very dissimilar from what the URC team actually saw. And there's so much to consider as a data scientist. At the end of the day, you really just want to be able to go ahead and work on your algorithm, work on your product, to be able to deliver that to your customers, hopefully get some feedback, refine it a bit so that you can come up with a really good data quality, really good quality product at the end of the day. And for us at ExxonMobil in the data and analytics team, that is not so much dissimilar. The pressures that we had really basically took us to look at how can we do this effectively and easily, and it looks like the slides are mixed up, and that's okay too. How can we do this effectively and easily within our groups? How can we go ahead and, for right now when we're starting with Jupyter Notebooks, that's where we started 2 years ago, how could we easily take that Python code, the graphical user interface, the documentation, and share that with our customers? We thought that Jupyter Notebooks was a really good way to actually do that, but there is a serious drawback with that. And when we look at that drawback, it's something that most people here would be actually very familiar with. You have your PC or your Mac. Okay, I'm not going to distinguish between those two. You actually have to go and set up that environment. Do you have local admin access to be able to go and add any of the applications such as Jupyter Notebooks? Do you actually have the ability to configure an environment? Do you have access to the data that you're working with? There are a number of things that you actually have to go ahead and set up so that sometimes you can go ahead and share your code with your actual colleagues and your users, right? We're going beyond the point where you've actually sat down, you've created something that's really special and you want to share that with somebody. Are you going to go to that person and say, by the way, I have something really cool that I want you to look at, but you're going to have to get local admin access. I need you to install these 5 or 6 pieces of software. Oh, and I forgot there's a pip install that you need for this portion of the actual code to work. Users, when they used to see me coming, they're like, no, I can't test anything. I don't have a week to set up my machine. And that's why we actually went with Jupyter Notebooks. We thought, that would be very, very good to start with. But again, we're actually dealing with that PC setup. So I was complaining about this to one of my colleagues who happens to be an architect and technologist at ExxonMobil, Chad Furman, and he said, well, why don't you take a look at OpenShift? He says that's an environment where you could basically go ahead and take, gosh, I'm really messing up with this. You could really go ahead and take this PC setup and you can actually put it into something that is a container, which is actually virtual, that it would be easy to share with your colleagues. So for us at the data and analytics team, we thought this was actually a very, very good solution. We could go away from the pain that we had of trying to set this up where we're trying to share things with each other and our customers, but as well too, we realize the prize because we're at the point where we're having some products that we may be ready for commercialization. Maybe not, we may be exploring them, but we have to be able to quickly cycle through those products in an agile way so that we can get more information, so that we can create that good quality product at the end of the day. And for us, that was really valuable to kind of consider and say, okay, that could be a start of a very good interactive environment. Let's go forward and see if we can do something with it. So what we ended up doing is just taking this local setup and actually putting it forth into a container. And this container, if you don't know what a container is, you can hit the Red Hat desk and they have a small handout on what container technology is. But if you can think of it as just an ephemeral type of machine, not a VM, that is fairly portable so that you can actually have your environment ready and then you can basically just go ahead and add your code to it, and then once you have your code, actually store your code within a Git repository. it's really good to have your code in a Git repository for those who don't share their code, because when you want to reproduce this later on, you want to be able to get that last set of code that you were working on and say, this is the fantastic code that I wrote that solves this algorithm. Enough said about that. But once you can go ahead and get that code, get that into that Git repository, and basically go ahead and have OpenShift be able to pull that information from that Git repository, which of course you have your container that's going to run your code, you actually come to the last part where you are actually ready to share this with your colleagues. Okay, you've created this fantastic algorithm, maybe you've solved an optimization problem, maybe you have a user interface and you're ready to share. You don't have to go and ask them what they've actually done in terms of setting up their PC or their MacBook, or if you've had to set up a server with your local IT team. What you simply do, and this is fantastic, you just give them a URL. That's it. You send a URL in an email and say, can you click on this URL, take a look at maybe some of the code that I've written, or maybe go ahead and even play with this application that I've created. And that's very, very powerful, because what it does is it frees you from the hardware that sometimes can be so painful when you're trying to set up something. And as a data scientist, I look at that and I say, well, this is, to me, a reproducible data science environment. I can now very easily take what I've done using that container and hand the whole thing over to somebody else to look at. But when I hand it over, I'm just giving them a URL. That's very, very simple and very easy to work with. So I don't know how many people know about Agile methodology. I hope most of you have heard about it a little bit. When you're working in the development environment, and it doesn't have to be even within a research company like we have at ExxonMobil, you want to be able to state your problem in such a way so that you understand what you're working on. Then what you want to do is you want to meet with your customers or meet with your colleagues and go ahead and suggest solutions that can help you deliver a very good product. And what you're going to do is you're going to go around in this circle until hopefully you come up with a product that everybody agrees on, or if you're working with some of your colleagues, some code that you can agree on. In the past, we would worry, once we've created something, is how would we deploy this? Well, I've just told you about OpenShift and being able to use containers. So now what we have is we take this portion that we've created before, which is really a data ops environment where you can successfully check in your code. You can go and now make use of this container, which would have your Jupyter notebooks, for instance, if we're creating a Jupyter application with your Python code. Some access to your data. I don't know if you want to use spreadsheets. Let's just hope that we've evolved from using spreadsheets and we're using some sort of database. And then again, having OpenShift deliver that to your user. And again, I can't emphasize enough how powerful this is, because it is just so frustrating to be able to come up with something really neat but have no way to actually share that with your users. And with this is very interactive, because what we do is within this Agile methodology now, we're getting this interactive feedback, and now we can really quickly cycle from the code that we're developing, checking it in and sharing it either with our user or our colleagues. And for a data scientist to be able to rapidly deploy this code to either my colleagues or my users and obtain feedback, whether it's good or not, and hopefully in all of our cases it's fantastic feedback that we receive from our users, is really valuable, and it's really agile. And it's really nice how OpenShift actually goes and takes care of these capabilities. Now, moving forward for ExxonMobil, the data science capability that we have now with this platform, and this platform is an approved platform within ExxonMobil, it supports things such as the Jupyter notebooks that I've talked about. But now what if you see some sort of technology that you really like? And of course, technology moves very rapidly these days. What if there is some sort of other data science package or data science language that you want to try? Well, you don't want to be put in a place where you can only pull from one area or one repository. And what we have is the concept of a Nexus repository, where if you see something really cool that you want to work on, what you can actually do then is take that package, check it in, And then we have the actual ability then to have that package virus scanned, released into our Nexus repository, and allow people to actually use that image for some of their data science work. The other thing that we have is recently, which is fairly new, is the NVIDIA GPU capability. We haven't tested that out at this point in time. Again, there are a lot of things that OpenShift supports that we've just barely scratched the surface on. For me in particular, it's being able to take that Jupyter notebook and add some of the Anaconda libraries that I needed to help me work on a curl optimization problem or an optimization study that we have, which I can't go into too much detail to because we had to peel the lawyers off of the walls just for me to like list this little part right here. But essentially, what I'm doing is I'm taking this platform, loading this code onto this platform, having a SQLite database where now my users in Calgary, via a URL, could go and take a look at that application and run that application and actually see whether or not the optimization of how they set up trucks to actually run around a mine and how some of that ore can then be, how do I say it, be used efficiently and create a certain blend is optimized to their potential. And that's very powerful. So I think the message that I'm trying to deliver to you as a data scientist or somebody who's interested in actually being able to deliver your product or your code, again, to your users or your colleagues, I don't care about anything else in terms of how I'm going to use the architecture, how I'm going to use the delivery mechanisms. At the end of the day, I want to have something that's very simple that I can use where I can check my code in somewhere, send a URL to somebody and say, take a look at what I've done. At the end of the day, for me, that's actually very powerful. So I'm going to hand it off to John to go forward.
Okay, thank you, Audrey. All right, so really what the end of the day, Exxon, anyone can be a data scientist at Exxon with this platform, right? This idea of a one-click notebook. If someone has an idea they'd like to use some of this Python code, go spin up something, get access to the data, that's been opened up inside of Exxon for anyone. So, the idea that you've always heard that the future's already here, just isn't well distributed. This helps kind of distribute these capabilities out to Exxon. 1 second here.
Yeah,
all right, so I'm going to go quick. So when we look at data scientists, they're a new breed of developer, right? Data scientists are, sometimes they have domain expertise, sometimes they came from a database. I mentioned these earlier, BI type of tool, type of backgrounds. But we've got newly minted data scientists. I think we're cranking them out very quickly. There's a shortage of data scientists out there today, according to Deloitte and all these guys that do these type of research, right? I think everyone has seen and probably have an advertisement in their email box, probably sent today, advertising one of these courseware things from MIT or Purdue or whoever. These programs are great, but there isn't a long tail of history of saying what is a data scientist. So there's people that have data science skills. What is a data scientist? I think we're still trying to establish that, right? In any case, they want choice, right? So at the end of the day, if you're doing an agile methodology or an agile shop, it's about choice for a team. You're able to use the tools and frameworks, database technology that you care about. A container platform gives you that choice, right? There isn't the idea of having a standardized set of tools out there. I can experiment and fail fast. I don't have to become expert on the latest Keras or PyTorch or whatever. But if I want to go check it out and spin it up very quickly, a container platform allows me to do that. Also, with their access to the GPUs, access to the data, doing curated, all the the bulk of the work still is data prep, right? The actual running of these models and doing all these things. Those things are actually the simple part. It's getting access to the data that you trust, that is an authoritative data source that you have full pedigree to. That's still the bulk of where I think there's work to be done, and how we're looking for additional open source projects to support those concepts. Ultimately, what we're trying to do is drive innovation, right? All these different technologies, all these new projects that are out there, connecting the IoT telemetry to the data scientists. That's where I focus. Getting stuff from the edge, train it, being able to do intelligent things on the edge is what some of these MLs are being used for like computer vision, leak detection, safety. All those type of use cases are powered with this capability. Specifically, one thing I wanted to mention here, I think a lot of people are probably familiar with Docker. Docker at scale is what Kubernetes is. The security features that we have in there, the ability to enable a DevOps pipelines, Jenkins ships with our platform. You can use any CI tool, but having a DevOps pipeline now maturing to what we're starting to call, I've seen people call data ops, some people call it science ops. In any case, it's having all this being predictable and reliable, and so that when I run it in this environment, I get the same answer as another user runs that same thing. That is still very hard to do. The thing with Jupyter Hub and some of these other technologies is also increasing the transparency of the science. You know, I think we've seen all these poster boards out here. You know, how they came up with those answers, I should be able to take that same code, that same data, all the environment configuration that they did, have that in my pipeline so I can then produce that reliably and repeatably. So then someone else, and then collaborate where someone can take my work and add to it. That's how innovation happens. And getting us where we have a community that can support these things and share is what we need to be able to go faster. So really at the end of the day, what OpenShift is you can think of it as Kubernetes plus, right? What we've done is take Kubernetes, which came from Google. If anyone's familiar with like a Google search, at the end, the back end at Google, that is a container, right? They've been working on this. There was a project called Borg for 10 years. They figured out how to be able to spin up at like 2 billion containers a day, right? That's where this technology comes from. It's able to subdivide a Linux box. And so what we've done is add in not only support for how to do it on premise, but for any cloud. So if you build on this platform, you've kind of built some insurance that this thing will run anywhere, so you don't get too sticky with your public cloud providers, right? So if I build something on AWS and I'm using value-added services on AWS, it only has value on that platform. The ingress and egress charges to these cloud platforms are the dangerous. That's what you need to design up front for, is understanding your data moving to these cloud platforms. And if you ever want to get off, it's a whole lot cheaper to get on than it is to get off. And so when I'm trying to advise folks how to be safe, be architecturally safe, that CIO level discussion, I call OpenShift a prenuptial agreement with your cloud vendor. So for anyone who's been divorced, you might understand the value of that. So, but in any case, what we've done is provide content on top of the platform that's been containerized, that is secure. Pulling stuff down from Docker Hub, there is risk there. Red Hat understands the security with Linux. Rooted containers is something that's out in the wild. You're starting to see CVEs show up that are attacking things on Docker Hub. So just pulling down stuff from Docker Hub, you need to put some security in place to make sure you don't do something that puts you at risk. So kind of what a data ops pipeline is starting to emerge. There's a bunch of different projects. I said Red Hat's really focused on supporting these things, containerizing and making them easy to consume and turn on. We can go spin up Kafka for you. We can go spin up Spark clusters on the platform in a matter of minutes, right? So I don't have to be an expert at Spark. I don't have to be an expert at Zookeeper, right? I can just go turn this technology on and leverage it. Here are some projects we're working on. So Kubeflow is TensorFlow on Kubernetes, right? There's a bunch of sub-projects associated with that. Model management is what Selden's focused on. PyTorch, TensorFlow, I think everyone's familiar with some of those projects. Those have been around for a while. Rad Analytics IO is a bunch of example data science projects that we support. So Red Hat has its own data science team. This is their output, what they've containerized, right? And so we've done some Apache Spark stuff. The source to image is that idea that I can just check in my code to Git, and we'll take of everything from compilation deployment to a running app for you. And now what we're starting to do is introduce something called operators. So while S2I was great at getting the application up and running initially, we call those day one issues. Day two issues now are what operators are focused on. How do I keep my applications healthy? And backup, restores, all those are built and described into the application.
Thank you, everyone.